This is exam 4, page 2, section 1, and this is problem number 1, and it states, suppose that the particle moves along a curve with acceleration defined by a of t equals 18t minus 4. Find the equation of the position s of t, and if the initial position started at 5 meters, with the velocity of 20 meters per second at t equals 2. So I just wrote down some information that we received from strictly the problem. And then from here, this is our equation. And we're actually going to start by trying to find v of t. So the antiderivative of acceleration is velocity. So we're going to do this. The antiderivative of a of t, d of t. So we're going to find the antiderivative of a of t. So it's going to be antiderivative of 18t minus 4. And then finding this antiderivative isn't too bad. It would be 18 t squared over 2, and then it will be minus 4t, and then we'll do a plus c because we have an unknown value. So plus c1 we'll say. But then this will simplify to 9. So technically this is going to be 18 over 2 is 9, so now it'll become 9t squared. So this is our v of t equation, and then we are trying to figure out c. But we're also given v of 2. So now we're going to use that, and we're going to set this. We're going to add in, we'll do this. V of 2 means that we're going to add 2 as a substitution for t, or for, yeah. So 9 times 2 squared minus 4, 2 plus c1. And then you're going to get 9 times 4, which is going to be 30 negative, no, it's going to be 36 minus 8 plus c1. And then we were told that v of 2 is 20 meters per second, so we're going to put a 20 here. And then we're going to solve for c1, so minus 8, and then we're going to do minus 36, and then we're going to get that c1 equals negative 8. So now that we know this, we have the full v of t equation. It's going to be v of t is going to be 9t squared minus 4t, and then it'll be minus 8 because that's what we figured out c to be. And then now we're going to go to position, which is s of t. So we're going to do same thing as acceleration. A s of t equals the antiderivative of v of t. So the antiderivative of this entire function, it's going to be antiderivative of 9t squared minus 4t minus 8, and then that's going to equal v of t, s of t, and the antiderivative is going to be 9t cubed over 3 minus 4t squared over 2, and then minus 8t, and then we're going to have a c2, so plus c2, because we're going to have another unknown value. And then we're told that the initial position is at 5 meters, so we're going to use s of 0, which we were told is 5, and then we're going to set that equal to our equation. but we're also gonna be plugging in 0 for the t's. So we're gonna have 5 equals 9 of 0 cubed over 3 minus 4 of 0 squared 2 minus 8 of 0 plus c of 2, or c2. And then this will end up being 5 is equal to c of 2, because all of these will just go to 0. So it'll be c of 2 is 5. And then same thing as we did before, our s of t equation. It's gonna be the same thing, but we're gonna simplify it like the tiniest bit. These divide, and it's gonna equal 3t cubed, and then 4 divided by 2 is 2, so we're gonna do 2t squared, then it's gonna be minus 8t, and then it's gonna be plus 5. You're left with this equation, and that's the answer. So